Okay, good afternoon, dear participants. I am Neringa Radžiukynienė. I am from Lithuanian Energy Institute, and today I'm very glad to participate in this international conference. And as you see, the presentations are going to the end, and I really hope to pay your attention, that you are still having some power to listen to it. And I really hope that my presentation will be quite interesting and innovative solution. Together with me in this conference came my colleague Artūras Klementavičius, as we were coordinators of this international project. So please take time during my presentation or any time to ask any questions from me or from my colleague. So the title of today's presentation is Horizon 2020 Project EnergyKeeper, Breakthrough to Sound, Flexible and Collective Energy Storage. And so, oh it's doubled. Okay, let's start. Actually, Lithuanian Energy Institute has had a honor to participate in a very interesting international project, EnergyKeeper. It was about energy redox flow storage solution, and this project was funded by European Commission. During the period of the project, we needed to move through the three main goals: to develop a new type redox flow battery technology, integrate the battery into smart grid environment, and demonstrate battery operation in industrial relevant environment. Maybe not everybody of you know what is redox flow battery or what is redox flow abbreviation. So redox flow batteries are electrochemical energy storage devices, and redox flow stands for reduction, oxidation, and flow. So reduction, electrons are bound, oxidation, electrons are released, and it means that they can move freely, and flow, liquids stored in medium electrolyte. EnergyKeeper, this project was made by international partners from 10 countries, including 2 partners from Lithuania. One is our institute. It was coordinator, and another Litgrid transmission system operator. Actually, we started this project from technology readiness level 3, and our purpose was to reach the 7th technology readiness level. And our motto was keep the energy at the right place. Yes, our project was under research and innovation action. It already is finished, and it took 3 years. Budget was 4 million euros, and as I mentioned before, it was funded by European Commission. And during the period of the project, we moved through 5 technology readiness levels: experimental proof of concept, technology validation in labs, technology validation relevant environment, technology demonstrated in relevant environment, and system prototype demonstration. And of course, under post-period of the project, our expectations are entering this product to the market. In any way, we can't escape from the chemical part, even if it is not very interesting and very easy, but maybe somehow I will try to explain you how this battery works. Under electrochemical storage covers conventional batteries and flow batteries. Conventional batteries, all of you, I think that you know very well, and the most popular is lithium ions battery. Another part is flow batteries, which is redox flow batteries, hybrid flow batteries. So redox flow batteries are divided in two main types, so vanadium-based and organic-based. Ecologically friendly for environment is our case and project EnergyKeeper. Talking about the concept of our project, it covers the technology object and physical body implementation and development. In our project, it was the development and implementation of battery with power of 100 kilowatts and with capacity of 350 kilowatt hours. The main task was how this battery to integrate into the smart grid. Actually, the development period of this technology had another aim: integration of renewable energy sources, electrical vehicles, chargers, and variable power consumption. And we had a demonstration in Akres test site. It is at the Wageningen University, Netherlands. Also, EnergyKeeper will develop several prosumer business models orientated to different types of communities in order to demonstrate that energy storage system will bring economic profit to end users. As I mentioned before, we made a prototype of this battery. It looks like a container. It was brought to Akres test site, Netherlands. And yes, you can see that it is two containers, electrolyte tank energy for energy storage and cell stacks energy conversion. This is how the one and another container looks from inside. One is IT part for management, and another is chemical part, so a little bit is visible somewhere here. Let me present the cartoon image of this testing, how it looks like. In the center, you can see local smart grid controller, and it is connected with various loads. It's wind plants, green houses and having on the roof the solar panels, and also electrical vehicle charging stations, and combined heat power plants, which uses fuel of gas. And somewhere here you see a connection point of smart grid to large power system. By this point, it could be connected to the network or disconnected. If disconnected, it is possibility to work in island mode, island regime. Also, important to mention that battery functionalities and controllability was tested. Battery interoperability and smart grid was proved during this testing period. Yes, we should discuss what was the advantages of redox flow battery. So the main four things was simple and safe. It means not flammable, not expensive, turnkey energy storage system, and low maintenance, and operatable off-grid, as I mentioned before. And also it's very clean, it's environment friendly, it's metal-free, it's saline solution as electrolyte, no aggressive acids, resource efficient and recyclable. And another point is scalable. It means that you can easily change the size of the battery. External energy storage and the power can vary from 100 kilowatts to 2 megawatts. But we started with 100 when we made testing in Agres test site, but actually it depends on client's need. And capacity also can vary from 400 kilowatt hours to 10 megawatt hours. And also it's very important to mention that this battery is economical. Low-cost resources, feedstocks, producible in Europe. It means that no materials or any parts of equipment brought from Asia. No risk of supply shortage. High planning security and, in my opinion, long service life. It's more than 10,000 cycles possible to do. Maybe I mentioned something a little bit of this before, but I can repeat a little bit. Here in this slide you can see all consortium what companies are involved in here. 2 Lithuanian companies, as I mentioned, our partners from Germany, Spain, Israel, Netherlands. And in this project was very good purpose reached. It was synergy between science, because Lithuanian Energy Institute is a research center, and between business. And actually, our project during all the development and implementation period was very strictly controlled by project officer. And he was supervising time by time us. And actually, we think that project was successfully implemented and be estimated as an outstanding project. Also, our project was pretended to get an award. Project officer recommended to apply a proposal for EUSEF award. What is EUSEF? It's European Commission. Yes, the biggest annual event dedicated to renewables and efficient energy use in Europe. And here you can see some members of our consortium. Let's get back to the chemical part of this project. It's not very detailed, but I will try somehow to show in the simple way, because my research area also is not the chemistry. So, as in conventional batteries, negative and positive charges are done in electrode. So in redox flow batteries, they are made in electrolytes. So following from this, in a catalyte tank and anolyte tank. And tanks hold and saline solution, and charging and discharging is achieved by pumping the saline solution through a cell. Through this process, electrons are bound and released, electricity stored. And what the expected result? Battery's power and capacity can be scaled independently of one another. The amount of electrolyte determines the capacity of flow battery, while the surface area and number of the cells determine its power. Very similar slide will be next, but I am not going to detail it because just for review, it's a little bit more detail, and it's natural that when you meet chemical things, you need to work a lot of. It's quite complicated. A lot of testing should be done, and you meet a lot of challenges. Challenges like in our project, we needed to prevent capacity decay, gas emissions, over temperatures, and viscosity of electrolyte. But at the end, we solved all the challenges and moved successfully somehow. Here I would like to show our batteries context. In our batteries context, most of companies are currently focused on lithium-ion technologies and electric mobility. Yes, at the moment it's the most popular maybe batteries, but redox flow batteries are flexible, stationary alternative to lithium-ion batteries, durable and easily scaled up to megawatt storage, as I mentioned before. Also, you can see here the pairings. Actually, I'm not going through all this, but the metal-free, low-maintenance redox flow battery is perfect for applications with high technical safety requirements. Here you see the hierarchy of smart grid, which consists of high voltage grid, medium voltage grid, and low voltage grid. Actually, SCADA, where is in high voltage grid, it controls distribution management system, and distribution management system has relation with grid control hubs of several, and grid control hub is connected with central grid control system. This grid control central grid control system, it controls redox flow batteries, and controlling them, they covers the needs of medium voltage grid or high voltage grid. Okay, and flexibility of storage gives opportunity for battery to participate in demand response business. In this case, in battery case, it will be battery management of battery charging and discharging. And for example, network operator, he requests 1,500 kilowatts in minus. So aggregator of residents activates community 1 and community 2 and changes the loads or generation and collects them, and later with the necessary quantity it responds to network operator. Actually, our institute was a lot of focusing on the creation of business models, and there are at least two classes of business models. So demand response and other ancillary services. So demand response could be a change of load or a change of generation, or also in battery case it could be charging or discharging. And the main buyer of these services is network operator, and provider of such a services is prosumer. In energy sale, it's a little bit different. The main buyer is market, in other words, supplier. Both these are built upon plus minus kilowatt or kilowatt hours are derived from load changes, generation, and storage charging, discharging. Also, what is good for aggregator, that it could be integrated in virtual power plant. And what is, first of all, what I'm talking about? What is virtual power plant? Virtual power plant brings together energy and flexibility, resources of its members, and sells it on the market. And a virtual power plant is a great option for communities. So you see on this picture a lot of collective storage communities, and each of it has redox flow battery, energy storage battery. And on another side, you see another players of market, which could be offshore wind parks, factories, shopping centers, hotels, logistics centers, etc. Virtual power plant is a group of distributed energy resources which combine to function as a dispatchable unit. And what is important to mention, that virtual power plant can be used for the purpose of participating in the electricity market or aggregating ancillary services. Until now, I actually talked about future perspectives, about the project which is not already pushed to the market, which is going to be entered to the market in the end of this year or maybe in the beginning of next year. Now I would like very shortly to review the present situation in Lithuania related with energy storage systems. I should say that a big promoter of such as technologies is our transmission system operator, Litgrid, because he has already promoted, implemented or developed, already 2 projects. One of it is quite small, 1 megawatt, and it was installed in Vilnius switchyard, and it was linked with Kaunas hydropower unit. What results were reached? A battery energy system with corrected parameters can compensate for asymmetries in the power curve of a hydropower unit. And before coupling, such 2 physically distant units can provide frequency container reserve services, and you can see the diagram below. Another project related with the Litgrid is huge. Is maybe the biggest in Europe, not maybe, but yes, it is. It's a project of 200 megawatts. Actually, it's total power. It's divided in 4 different places. One battery is installed at the same place as previous battery in Vilnius switchyard. Another will be actually maybe not correct to say installed, it's on process, or yeah. Another should be installed in Šiauliai, Alytus district, and the last one in Utena. This battery will restore the system in emergency situation and resume energy supply for rural Lithuania in seconds, and will contribute to the rapid integration of growing renewable energy sources by storing solar and wind power and returning it to the grid if needed. As you see, the project is huge, and the budget of it actually is also very big, 109 million euros. It was funded by European Commission and project implemented by Energy Cells, which is the part of state-owned EPSO-G group. And actually, I would like to come to the conclusions that, in my opinion, our project EnergyKeeper was implemented quite successfully, because we moved through the 5 TRLs, and actually we are nearly post a project period in entering this project in the market, reaching 9 TRL almost. And also we think that this battery is quite competitive with lithium-ion batteries. And what will be clients for our batteries, so network operators, as well as demand responsible batteries, who are wind power plants, solar plants, big industrial consumers, energy communities, and ESCOs, energy service companies, in other words. And we created this battery, which should be saving your money, which should be ecological friendly for environment. And I am coming back to our motto that keep the energy at the right place. So we really hope that our battery is that place where the energy should be. Keep it correctly. Thank you for your attention.
Thank you, Neringa. Anyone? Thank you. Okay, we have one question.
Maybe a short question. Thank you very much. I'm not a redox flow battery expert, but I believe there are a couple of companies already on the market, like Siemens, Schmidt, and I think they are using vanadium, if I'm not mistaken. Yes, so this what I wanted to ask. What is the chemistry behind it? Maybe you showed it, but I didn't see it. It's based on which?
Say, how is that in English word? Druska. Yes, saline solution, sorry. Yes. Yeah.
Anyone else? Okay, thank you, Neringa.